Lesson 5.2 is on adding and subtracting like fractions. This should be a review as you've been doing this for many years, but our last examples will be adding in the components of variables. So please refer to these as the foundational rules though. So lesson 5.2 is when we're talking about like fractions. Like fractions mean that they have the same denominators. So 7 hundredths plus 9 hundredths, as long as they have the same denominators, we can go ahead and we can just simply add going across. So we get, we don't get 17, we get 16. My goodness, 16, and that's an ugly 16. We'll try this one more time. We get 16 1/100ths. But once you get that, you need to make sure that if you can simplify. Now remember, when simplifying, two even numbers, so we could divide by 2, but there's another number that's a little larger. So we're going to divide both the top and the bottom by 4. Now, 4 over 4 equals 1. So again, a review of a foundational skill. We can multiply or divide any number by 1 and it will stay the same. In the world of fractions, it simply changes its name. Like Michael is Mike, or even Mikey, but it is the same person. So 16 divided by 4 is 4. 100 divided by 4 is 25. And neither of those numbers have a number that will go into both of them evenly, so that is in its simplest form. Now we're going to do some subtraction. Again, we have common denominators, so all we need to do is subtract going across. Notice they did put the addition of an integer there. So we have -4 minus 2. We can, if you need to, go ahead and add the opposite. We have the same sign, so it stays the same, -6/7. And there is not a number that goes into both of those numbers evenly, so that is in its simplest form. Again, I'm going to use a different color here so you can see 1/10 minus a -3/10. So we're going to add the opposite. 1 plus 3 would equal, let's go back to our chalk-like, 4/10. Both of those even numbers. 2 is the biggest number that goes into both of them, so we have 2/5. So we did add a couple new concepts that you might not have practiced before. Our integer rules, however, we've been practicing since the beginning of the school year. Now we're going to add and subtract mixed numbers. Now, I'm going to show you this one the same as it's in the book, in case you're using the book as an extra resource. When you're adding mixed numbers, it is okay to leave them as mixed numbers. However, there is no such rule there is, but you'll have more problems. We will not do subtracting mixed numbers in this way. I'm going to show you both ways for the addition as well. So if I add this, I'm going to add my whole numbers. That would be 7. And then 5/9 plus 7/9. I have common denominators. So I can go ahead and just add those. I have 7 and 12/9. The problem with 12/9 is that that is actually an improper fraction. So that's the same as saying 7 plus, and if I change 2/9, it would be 1 and 3/9. I could simplify that, but I'll wait till the very end. Now I have 8 and 3/9, and simplifying that changes to 8 and 1/3. Now, if I am going to subtract mixed numbers, this time to subtract the mixed numbers, I need to go ahead and do some renaming. Subtraction has a little bit different procedure because of renaming. I'm going to need to pause here 1 minute. Continuing with mixed numbers, for subtraction especially, and I would just use a routine for addition and subtraction. We want to change our mixed numbers into improper fractions. It is especially necessary. Do not go away from this rule. It is especially important with subtraction because of the borrowing. So you absolutely have to change mixed numbers to improper fractions when you are subtracting. So you can do it with a calculator. So to change negative 10 and 6/13, it's still going to stay negative. On your calculator, go ahead and plug 10 times 13, because that means we have 10 whole ones, each cut into 13 pieces. That would be 130. You can probably do that one mentally. And then we already had 6 loose ones, so 130 plus 6 gives me 136/13. Now I'm going to subtract, do the same thing here, 6 times 13, and then you're going to add 8, and you're going to end up with 86/13. Now because it's subtraction and we're with integers, we could go ahead and we could add the opposite if that makes it easier for you. And so negative 136 plus a negative 86, we have like terms, so we can go ahead and add those, and we're going to get 222/13. Now again, we can use our calculators and change this back into a mixed number. What we're going to need to do is we have 222 pieces. We want to put them in pies that would be 13 each. So 222 divided by 13. Now when you do that on your calculator, you're going to come up, oh, Ms. Homan forgot her negative sign here. You're going to come up with a negative 17, and then there's going to be some decimal points. You're going to want to write negative 17 down, and then you're going to want to clear your calculator, and you're going to say, okay, I want to know how many pieces I used, so I'm going to do negative 17 times 13. When I get that, it's going to be 221, so that means I have one piece left out of the 222, and that's going to be over 13. So my final answer is negative 17 and 1/13. Make sure you pause this if you're not sure how to use your calculators to change fractions, mixed numbers into improper fractions, and improper fractions into mixed numbers. So now we are ready to put in some variables. Whoops. Well, we're having a little bit delay with our oh no, what happened here? I've lost my one with my integers. Let me see. I mean with my coefficients. Here we go. All right. Now we're going to go ahead and we're going to add fractions still with common denominators. We still have a common denominator of 20, but we threw in some variables, variable expressions. So when we do this, we're going to keep our common denominator 20, and then we have like terms. They're both a terms. We have 3a in one place and 5a in another place. Combine them together. That will give us 8a. Now we need to go ahead and simplify. Now simplifying is going to be that I'm going to divide the top and the bottom. The largest number, that 2 goes into both of them, but this will save you some steps. A bigger number that goes into both of them would be 4. So 8a divided by 4. So I could put those into groups of 2a in each group. 4 goes into 8 2 times, and I'm still in a's. And then 20 divided by 4 is going to be 5. So my final answer, written a little bit nicer, is 2a over 5. We're going to do the same thing with subtraction now. So let me go ahead and rewrite this first of all. We have negative 8 minus a negative 2. If I'm putting it like this, might help a little. And our common denominator is 3b. So if you need to, go ahead and add the opposite. We have different signs, so find the difference. Difference between 8 and 2 is 6. And the negative value was larger, so negative 6 over 3b. Sorry, the connection's not working quite as well. I'm getting some dotted lines there. So negative 6 over 3b. This time you notice that the variable's in the denominator, but I can still do some reducing. I'm going to go ahead, I'll change colors here. A number that goes into both of those is 3. So I'm going to go ahead and I'm going to divide 3 by 3 would be 1, and negative 6 divided by 3 would be a negative 2. So now I can go ahead and write my simplified. I have negative 2 as my numerator, and I have 1b, and we know we can write that simply as b. So that's negative 2 over b. And that concludes, and believe it or not, this is about the third or fourth take since my pause, but that concludes lesson 5.2, hopefully.